exponential function, it's a function in the form f of x equals b to the x, where that's an exponent, and b is greater than 0 and not equal to 1. It's called a base b exponential function. So let's look at a few examples. Evaluate the exponential functions if our function is 3 to the x power. So when it tells me to evaluate function notation f, evaluate it at -3, it means that I'm going to write my function down, f of x is equal to 3 to the x power, but everywhere there's an x, I'm going to plug this in place of x. So it's going to be 3 to the -3 power. Now, rules of negative exponents means if it's a negative exponent in the numerator, I can bring it down to the denominator and now it's a positive exponent. So then that's just 1, and then 3 to the 3rd power means 3 times 3 times 3, which is 27. So this is going to simplify to 1 over 27. We're going to do the same thing for b. We're going to write our original function down, which is 3 to the x. And then everywhere there's an x, we're going to substitute 4 in place of that. So that would be 3 to the 4th power, which would mean 3 times 3 times 3 times 3. In this case, that equals 81. And we'll continue on to c. So it says write your f function down, which is 3 to the x, and then evaluate that when x is to the 2/3 power. So 3 raised to the 2/3 power. If you put that in your calculator, you should approximately get 2.08. And when you put this in the calculator, you may want to put the 2/3 in parentheses, so 3 raised to the 2/3 power, just to be precise. And then on D, we're going to write down our function, which is 3 to the x, and then we're going to plug 2.1 in place of x. So it's 3 raised to the 2.1 power. On most calculators, it's the little caret button like this, 3 raised to the 2.1, and it would give you approximately 10.05. Like I said, on a lot of the calculators, raising it to an exponent has this little symbol, but not all. Alright, in this next portion, we're going to talk about properties of exponential functions. Basically, the domain, which is our x values, are going to be from -infinity to positive infinity. And the range, which is the y values, is from 0 to infinity. And we see that in both circumstances down here. So domain, -infinity to positive. Range is the y value of 0 and up. Same thing over here. 0, 1 is always a point on the graph. So here's 0, 1 right here. And if we're talking about this situation, there's 0, 1 over there. There's a horizontal asymptote at y equals 0, which would be here. And that just means our graph is it's going to be approaching that line. Okay, so that's a horizontal asymptote. It's 1-to-1, continuous, and smooth. If b is greater than 0, that means if this number is bigger than 1, you're going to have a shape that looks like this. If this number is less than 1, or in between 0 and 1, more precisely, like for example, if b is 1/2 x, in between 0 and 1, then you're going to have this going on. Okay, so it's going to appear to look more like this shape. So we can see we have conditions in respect to the base, as if we're going to be looking at an exponential function here, or an exponential function over on the other side in red. Okay, so the next thing we're going to do is we're going to sketch the graph of the following. Now we can use our previous knowledge of transformations and our shifts to have a good idea of what's going on, but we can also set up a table of values pick some x values, substitute y value, substitute in for x and solve for y to get an idea. Now we said we knew that 0, 1 was going to be because it's a when x is 0, that would give us 4 to the 0 power, which anything raised to the 0 power is 1. Okay? But what if we had 1? If we let x equal 1 right there. So that would be 4 to the first power is equal to 4. So over 1 up, that would be this ordered pair, that point right there. What if I let x be 2? Then that would be 4 squared, which is 16, and you can see this thing gets a lot bigger, so 16 is going to be way up there somewhere. So basically the graph of our function, I didn't draw the greatest line, but you can see that it's going to have this shape right here, and this was the ordered pair 0, 1, and this was the ordered pair 1, 4, and that one up there is going to be 2, 16. So we can get a rough sketch, we're given sketches here of the graph. Alright, for f of x is equal to 4 raised to the x minus 2 power, that's kind of small. Just using our rules for transformations, we can look at this and say that this thing is shifted to the right 2 units. Using transformation, using our previous knowledge of transformation, which means if I would usually have 0, 1 on my graph for all of my exponentials, if I shifted that to the right 2 units, it would be here, which is the ordered pair 2, 1. But let me just take that away for a minute, and let's say I didn't remember that. I didn't remember transformation, so if all else fails, I can make an XY table. And let's just verify this. So when let's do an x is, what do we have over here? 2. X is 2 just because I made that point using transformations, but let me pick 2. So that would be 4x minus 2. So if I let x be 2, I would have 2 minus 2, which would be 4 to the 0 power is equal to 1. And yes, you know what, it did verify that our transformation works, but let's go ahead and get a few more points. Let's do when x is equal to 3 this time. I'm going to use the same. This time I'm going to let x equal 3, so I'm going to put the 3 right here. 4 to the first power is 4, so the ordered pair 1, 2, 3, 4 is on our graph as well. 3, 4. Let's just choose 4. We'll keep this simple. So that would be 4 minus 2 when I let x equal 4. So that would be 4 to the second power, which is 16. So 4, 16 way up there again. So we have okay, and this is not going to cross the x-axis. I know it looks like it's touching it because my pen's a little bit thick to draw precisely, but there's an idea of what this graph looks like. Now, before I move on to the next part, I want to remind you, part A was f of x equals 4 to the x. It looks similar to this one, except for it went through the origin at 0, 1. Or it went through the ordered pair, I'm sorry, 0, 1. And then this one was shifted to the right 2. So we shifted to the right 2. Considering that, what do you think this means? That would mean shifted to the left 1 unit. Okay, and then what do you think this minus 2 means? If you remember transformation, yes, that means down 2 units. Okay, so just by using our rules for transformation, we can kind of have an idea of what this thing's going to look like, but I'm going to use my table to verify some exact points. So this, remember, we think opposite, so it's to the left 1, down 2. So let me just, if I started at 0, 1, okay, which is on every parent graph of an exponential function, and I went left 1, down 2, left 1, down 2, that would put me at this point right here. Okay, so I'm expecting that I'm probably going to go through that point when I actually do my XY table. So I'm going to move that up and check it. Okay, let's pick some values. Let's do -1, 0, and 1. So 4, I'm going to let x equal -1 this time because I'm doing -1. So I'll put -1 plus 1 and then my original problem. So -1 plus 1 is 0. So that becomes 4 to the 0 power minus 2. Anything raised to the 0 power is 1. So 4 to the 0 power is 1. Minus 2 would be -1. -1, -1. And that's the point I said, I think I'm going to end up on this point because we tested it with our transformation. So we verified there. Now let's just get a few more to be precise. Okay, this time I'm going to let x be 0. So I would have 4, 0 plus 1 minus 2. Make sure you distinguish the exponents with the numbers that are whole numbers. So 4 to the first power, which is just 4, and then 4 minus 2 is 2. So I'm going to plot the order pair 0, 2, and then last I'm going to get one more point for the sake of a good sketch. Everywhere there's an x, plug in a 1, so that would be 4 squared minus 2. 4 squared is 16. So it's the ordered pair 114, which is going to be up there. So, whoops. Let's see if I go back and try that again. Okay. Approximately, like I said, rough sketch. Try to go through those points as best as possible. Probably a little bit better than I do. But that's the ordered pairs -1, -1. Order pair 0, 2, and of course up high is the order pair 114. So you get an idea of how we can do that.